First off, I welcome you all to another time. This is the fifth day, and then I'm kind of impressed with the progress we've made. Going from the very basics of Python, and then at least we've gotten to a point where we did a little bit of OOP, and I think that's some appreciable progress. And then I need to commend everybody for their dedication, and then I promise you that it's still going to be a lot more interesting going forward. So I gave some assignments. If you did the assignment, show of hands. Let me see. Raise your hands. If you did the assignments, indicate by show of hand. So let's start from there. I did my assignment. Just show your hands. Okay, raise your hands. I did my assignment. I did my assignment. Okay. Just one person, really? Just one person is raising up his hands. Two people. Okay, that's much better. Three. Okay, great, great. So because of time, I plan to allow maybe two, three people just share their screens and just explain how they went about their assignments. But let's just see what it will take for one person to do it. So first of all, I'll allow one person share a screen and then just run us through how it solved the problems. So without further ado, let me know. So the three of you raising up your hands, Taiwo, Timolai, and Akogo, Joseph. Is that all? Okay, if you did it but you didn't finish it, I don't believe just three people did the assignment. That's not impressive. Okay, if you attempted it but and then you got stuck or you didn't finish or you were overwhelmed by the questions, let me see. Let me just share hands. Okay, I tried it out, but when I read the first question or it was at the point of reading the third question, I was thrown off my feet, and I couldn't continue. So let me also see your hands. I attempted it at the very least, you know. Okay. I thought Poluwatife said she did it and then it's not with her. How she knows in her hands? Okay. Okay, that's still fine. That's still fine. We attempted it, Joseph. That's all that matters, right? So it's the is the is the commitment you put in that really matters. So at least you tried to do it. So now, if perhaps you see the solution, you can relate better. You'll be able to relate better to it. You get so it's okay if you tried it out but you couldn't complete it. All right, so three guys are raising up their hands, and then I don't know. Let me just allow the first person on my screen because this is the first person on my screen, and I'm sure it's the first person that raised up his hand. So I'll allow Timilane to share a screen and then just guide us on how he solved this problem. So Timilane, let me know if you're ready to share a screen. Can you just type yes, I am ready in the comment section so I know you're ready to share a screen and then we move on. That's if you're ready. If Timila is not ready, the next person, maybe I'll go with Joseph and just share his own screen. I just want it to be as interactive as possible and then get you guys engaged as well. So that's why I want you guys to share. Timila said he's not ready. Okay, Joseph, are you ready to share your screen with us? It doesn't have to be some fancy, neat code and some interesting. They are very basic, questions, especially questions 1 to 5. I guess just question 6 and question 7 will involve, number of lines, never up to 10 lines of code. So apart from those two questions, I don't think they are very difficult stuff to handle. So Joseph, let me know if you're ready to share a screen, or Boluwat, if you say you're now with your system, if you can also share a screen. Okay, you're attending this class with your mobile phone. Okay. Okay, that's okay. So who is using his PC and then can share a screen? Nobody? 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 Okay then. Okay, I guess nobody is willing to share screen. Okay, Joseph, but you have to be fast because we're running out of time. I want someone to at least share a screen and then I'll do the correction and then we'll get into the business of today. So, and I don't want us to waste time on this segment. So, Joseph, um, we are waiting for you. We are waiting for you. Okay. But I guess next time you guys should try to use your PC. Solomon, you said you're also using your phone. That's okay. But I guess next time you try to use your PC so that you're able to code along with me. I think that should be the way you guys do it. I don't want to believe that you guys don't write codes as I write them here. The best way to learn is actually by doing. And then the last class, I found out that who was that? I think the person's not around. Kamaluddin, I guess. After the entire class, when he shared the screen, I was shocked that his his codes were the same thing as mine, as though he copied it. Definitely didn't like copy and paste. He wrote as I was writing, and then I was very impressed with how he was able to cover everything that I typed on my own screen. So that's actually how to learn. So you write as I write, and of course listen, and then afterwards, even when you're reading your codes, you understand them better because you were the one that typed them. Or if you do not understand the particular syntax or why I used indentation or why I used apostrophe or square brackets and all those stuff, parentheses, you would ask the question on the spot. Oh, why did you use this thing here? Why did you use this here? So it's always good to code along with me. I guess that's the best way to learn. So Joseph, I think I must have bought you some time and you should be ready by now. So Joseph, let me know if you're ready. Okay, that's great. I'll give you that permission. First, let me allow you unmute your mic, and then let me give you that permission to share screen. Just a moment.
Hello?
Yeah, Joseph. Yeah, let me just allow you to share your screen. Okay. Okay. So I think you should be able to share your screen, Joseph. You should be able to share your screen.
Hello?
Okay, that's great, Joseph. That's great. I can see your screen. I don't know about the others. So everybody, if you can see Joseph's screen, say yes. I can see Joseph's screen. Let me just know you guys. Let me know if you guys can see Joseph's screen because I can see his screen. I can see. I can see his screen. I mean. Okay, so everybody, I think everybody can see your screen. So Joseph, please write down. Let me. I don't know. Okay, so Joseph, write down. Let me read. Okay, you can just write down. Let me give you 5 minutes to do what you've got to do. So your time start now. Joseph, you have the floor.
Okay, good evening, everyone. I was only able to attempt 3 questions out of the 7 because I actually ran out of time. I did the whole thing at midnight last night, thereabout. So the rest I slept up, then went to work. That's one of the most reasons. So I've not actually looked at it throughout the day. But for the first one, the first question, which says write a program that prints the list of numbers from 100 to 170.
Yeah.
For it, this is the first one where you have to actually have your list of numbers open there, and then you now use the range,
Yes.
for the numbers you want to print out.
Okay.
The range is from, you have to actually start from 100 and it has to be to 171 so that it will also take 170. Because if you just leave it at 170, it will stop at 169 because the counting starts from 100. So, and then you append the number. Then at the then there's a condition here which if number is greater than 170, you should break the loop,
Okay.
the for loop. Then you actually have to print your list. So this is the output for the first one.
Okay, looks good.
Yeah, and then the second one is write a program that prints a list of odd numbers from 50 to 100. Right? So it's actually almost the same way with the first one. Just a little difference where you have your if statement here, where your if the number percent 2, because these are actually what will give you odd number.
Okay.
Okay. Yes, this is actually what will give you odd numbers. From 50 to 100. And your range should be from 50 to 101. So here, when you append number, you print odd numbers. So it gives you this. It's just a few line of code that
Okay.
you have there. Yeah, and then for the third question, just 2 line of code. Right? The third question says write a code that asks for a user's name and returns hi / the inserted name.
Okay.
And then here is the line. You just have your user, so you have to use the input function here for
Okay.
you to be able to enter your username. Whenever you run this, you actually have to enter it. Sorry, let's just say this. So you can see you have to enter a username. When you enter any username, it says hi, whatever name you've entered,
Okay.
and then that's for that. So I was actually battling with the I think that's the fifth or the fourth one actually.
Okay.
I got somewhere around, yes.
Ah,
It was actually going well at the point. Then somewhere around here, I think where my if user input is equals to hidden number, you should print
yeah.
you're a magician. Else you print you have been logged out,
Yeah.
and then that I don't know.
Yeah,
That
yeah.
didn't really
First off,
really go.
I told you that indentation error or syntax error are kind of like the simplest errors to fix. Once you start doing
Yeah.
indentation error, it means that you didn't actually put an indentation where you should have. And then, although there are other things in your code that I would want to also correct, but for now, the first thing
Okay.
I would notice is that after using any if statement and you've added your condition, so you said if user input is equals to is equals to hidden number, you should put a colon there. Okay,
Okay.
it's very
Okay.
important. So if you put a colon and you press enter, Python automatically creates the indentation for you. So if you press enter now and look at it, you can see that it has created an indentation for you. So that prints you're a magician should be inside the indentation. Do you
Okay.
understand that?
Okay.
So I think that's where. So try to do that here. Okay, take it back one step. I think there's still one more indentation. Good. I guess it's so. Try to replace it. Let's see. Let's run it. No, wait. I'm confused. It said counter is equals to counter plus 1. Why did you have 2 equals to sign? Are you comparing?
Oh, okay.
You should
Okay.
add. You should increase. Yeah? Okay. So try to run it down. Let's see. Okay. Okay. You see, the thing is, he added one space bar before the if. If you notice the if the counter is equals to that line before the if statement, it's not aligned. Okay, so you should take one space out. Okay, so run it again now.
Okay.
Okay, so
All right.
so try it out.
Okay.
Try it out. Try it out. Let's see now.
Okay. All right. Uh, Let me just say okay.
Okay, wrong numbers first. Okay. So it didn't. Well. Wait a minute. I guess this is going to be this is an infinite loop. Okay, wait. Scroll down and listen. Let's see the errors bringing. It said hidden name is not found. Okay, that's interesting. So now I think you made a mistake with your spellings. And all these mistakes I'm seeing are actually the mistakes people make, even me, I make sometimes. Okay, so you wrote double DEN when you're creating that hidden name variable. But when you're
Yes,
comparing, you use
that's true.
D double E. So fix that.
Yeah.
Fix that. Okay, run it again. Let's see. Okay, now, right now. Okay, good. Add on again. Type it, because it's wrong, of course, so you have to keep on typing. It's fine. Okay, 5 tries, right? Okay. Okay, so you've been logged out because you entered. Okay. So one thing I would like you to do, your code looks nice, but you can still do much better. One thing I would like you to do is now enter your real number. Enter the correct number now. Enter the right guess. Okay, enter the right guess now. So the right guess is 8290, right? So enter it now. Okay, so you said you're a magician, but I still told you to enter another case, which is not proper.
That's it. Okay.
Yeah, so you should have used a
Yeah,
break
that's true.
statement, right? You should
A
have
break
used,
statement there.
yeah.
Yes.
So if that prints it, then break. Do you get? So it breaks out of the loop. Okay.
Okay.
Okay, so just finish up this code before you can run the game. So you have to finish up this code. Just type in some numbers at least 5 times. No, you run it again, and that's a problem you make. So now you're kind of you're putting your Jupyter notebook to run a code while a code is still running. So this will never run. And perhaps this is the mistake you guys are making. Do you get? A code is actually in session, and you're running another one. That's what we cause that complete, and so you have to end this kingdom. Do you understand what you did there? The first code you ran was still running because you had not
Yeah.
imputed the stuff 5 times. You only did it once. So that code
Yeah.
was still running, and then you ran this again. So this will never run because that one was still running and you didn't finish it. So it's just it's give you asterisk forever. So you have to restart this calling. So quickly or stop. Click on that stop button so to stop this calling at least. Yeah, so interrupt it. Have you stopped it? Okay, great. Now run it again now. So run this again now. Okay, so now of course input the right number. So let's see if that breaks the number. Okay, and that's it. So you wrote your magician and then broke out the. Yeah, so I guess that's a good one to say. So thanks for your time. Thank you so much. You can stop your sharing while I take over from you. So it's really impressive how, I mean, I know that, okay, someone has, put in some effort and then has done something impressive. At least it did about 5 questions, which is really good. Really, really good. Okay, so that's impressive, Joseph. I must commend you for that. So let me, at this point, share my own screen. Let me share my screen so we will get on with today's class. Okay, so I'm going to share screen right now. So I'm going to share. Okay, what's going to happen is a lot of people have come to me on my DMs on WhatsApp, and then they said that their Jupyter notebook is not working for some reason, and but Spider is working. And I actually told them that well, Spider can actually work like a Jupyter notebook. So for this particular exercises, I'm going to use Spider, right, to do the problems, and then when we are going to today's class, we go to Jupyter notebook. So let me share my Spider screen now. So let me just share it. Okay, let me create this. This was a file of ones. Let me open a new file. Okay, and let me just call that file. Let me just call that file. So I'm going to save the file. All right. I'm going to save that file. Okay, so let me save the file as let me just save it as new. Okay, assignments. Okay, let me save that assignments. .py. Okay, because it's a Python file. Python file has a .py extension. Okay, but a Jupyter notebook file actually has an IPYNB extension. So it always ends with a .IPYNB. But a normal Python file is, of course, a py extension. So I've saved this now as my assignment file. So let's begin straight away with the assignment. So let me go to my laptop and then let me scroll up to find the questions. Those questions, I formed them right on the spot. It was something I typed right in real time. So they may not be the best of questions, but I felt that these are questions that will actually make you guys remember, recall the things we've done thus far. So the first question says that write a program that puts list of numbers from 100 to 117. I guess you guys have seen the codes from Joseph, the code from Joseph, but I'm just going to use another method. This is a shorter method, and that's list comprehension. Okay, so I'm going to use list comprehension for this. I'm going to use list comprehension for this assignment. So let me just do. So if I want to do list comprehension, I'll just say X. Okay. Now, what is X? Or where does X look over? So I'll say for X in range of what's the range again of numbers want to look over? So let me confirm that. So 100 to 170. So I'm going from range of 100 to 170, but because it's a range, I stop at 171. Okay, so the thing is, when you're writing in Jupyter Notebook, of course, you know that everything is done in different cells. So you have cell 1, you run it in most and that cell, cell 2, you run it in most and that cell, and all. But on Spider, everything is just one, one stop. You get there's nothing like cell. It's just one Python file. And then, but how do you run these things in terms of cell? For instance, I've done this. Let me also write a print statement. So let me just print Alo-1 here, just to show what I'm talking about clearly. So on a normal day, right? If I run this Python file, it should do this. This is the solution to the first question, and then print Alo-1. But on Jupyter Notebook, on Spider, you have to highlight what exactly you want it to run. Okay, so if I wanted to run Alo-1, I'm just going to highlight this line like this, and then I run it with. And then as you can see here, this is like my my terminal of my console. It prints Alo-1. Okay, so that's it. So now let's say I want to run this. Now notice that I didn't highlight this Alo-1. So if I run this, it's only going to run this particular it's only going to run this particular line. So let me run this and you guys will see. So as you can see, it prints out my numbers from 100 to 170. Okay. So if I want to run all these, both of them together, I have to highlight all two and then run. Okay. So you can see. Okay, then I should have put a print statement here. That's the thing. So if you don't put a print statement, it's only the last thing that can get printed. If I don't put a print statement, it's not going to print for me. So I should put this print statement there and then run again. Okay, so as you can see, it printed that out. Okay, and then printed Alo-1. So this is how Spider runs, but I personally don't. It's good. It's good for some situations, but I don't like it. I really don't like it. So it's very good, in fact, because it works with the Pi, the Pi extension, which means that you can try to sync it to something like VSCode and all, or you push it to GitHub and then it will come out well. But let me just go back to Jupyter Notebook. But this was just to show guys that in case you want to use Spider, this is how Spider operates. So you kind of create the cell yourself by highlighting what exactly you want the code to run. If I don't highlight anything now, you find out that nothing will happen. Look at that. I've pressed my run button, but you see nothing happened. Right? Okay, maybe you guys don't trust me. Let me click on this run here so you guys will believe me. So you can see clicking. Okay, if I click on the run, I can now tell it what exactly to run. Okay, so that's one thing. So if I click on run, it's by default it ran the entire thing. Okay, but if I'm doing it with my keyboard using Control and Enter, it's not going to run anything. Okay, but if I highlight what exactly I want it to run, then it's going to run what exactly I specified it to run. So if I click on that, it's going to run that, and then if I click on this, come on. Okay, I click on this, going to run this separately. So this is how Spider works. I hope this has solved the problems of people that want to use Spider, but they can't. This is actually to show the saved objects. Okay, when you're working with, for instance, we're working with data frames, list, and all. Any variable you saved will be shown here. Okay, so that's how this works. So let me see if I can just show that. Let me call a variable X, and let's call it a list from 1, 2, 3. And let me just run this. Okay, it didn't show you as I wanted it, but I'm sure that if it's a data frame, for instance, it's going to just show that a data frame has been created, and then it will be here somewhere. So you can just see the data frame, and then you know all the variables you've stored in data frames and all. So that's how Spider works. I'm not a big fan because of this highlighting. And then, of course, it doesn't do the interesting stuff of opening and closing, my apostrophe automatically. So I open an apostrophe, I have to close it myself, which, of course, I'm not a fan of. Sometimes it just spoils my code for me. So I'm not going to use that. So let me get back to Anaconda. So let me stop the share. Okay. And then let me share my Anaconda notebook. So I guess it's Anaconda. This will Jupyter notebook. So this Jupyter notebook, I'm creating a new Python file. Yeah. And then let me call that file, right? Let me call that file D5. Okay, so D5. Okay, so now let's now solve our assignment. I solved the first one already using list comprehensions. I also solved the second one using list comprehension. So it said, write the program that prints a list of odd numbers from 50 to 100. So again, I'm not going to use list comprehensions. I'm going to say X or X in range. Okay, range of what? So I'm doing 50 to 101. Now, so I'm going to say, right, if, okay, because of course, I'm not printing all the numbers from 50 to 100. I'm only printing numbers that are odd. So I would say that if X, okay, this percentage of 2 is equals to 0. Okay, so if I run this, you find out that it's going to just print odd numbers. Okay, I'm sorry, this should be 1 because this is like a remainder. Okay, so odd numbers, of course, 3 divided by 2 is what? 1 remainder 1. 5 divided by 2 is 1 remainder 1. So it returns the remainder. Okay, so I should put 1 here and print in odd numbers. So around that, as you can see, you're going to print that. So I want to make it nicer. I can just put a print statement here. Okay, and then you can see it prints all your numbers from 50 to 99. I think that's all. So I'm going to move to the next question that says that of course, write a program that asks for a user's name and returns I and user's name. So that's also a very simple thing to do. So I can just say, okay, there's one thing I also wanted to point out in Joseph's code, but skip my mind. Joseph, when you're writing variables, okay, it's always good to have your variables start with lowercase. I noticed that what you did with your variable naming was that you did this. There's no problem with this, but it's not good practice. Okay, there's what we call PEP8, and PEP8 is just like a system that gives you the best practices on how to code. Okay, so from PEP8, it's always good practice to code or to write variables with start variables with lowercase, and then if you're writing more than one word, you space them with an underscore. I noticed you did that, which is good. But when starting out, please start with lowercase numbers. Okay, so name. So name is going to be inputs. Okay. Please enter your your name. And put a space because if we don't put a space, it's not going to be jam packed. So I'm not going to say print hello, and I'm going to print the name. So of course, again, I have to put a space there. If not, yes, the name and the hello will be together. So I run that and we print something like Joseph. Joseph, I'm going to say hello, Joseph. It's as simple as that. Okay, very simple points. Okay, so we'll move to the next one. The next one says that create a list compression that converts a list. Okay, that was from 1 to 10 to this kind of list. Okay, so let me just copy this so that I'll know the kind of answer I should expect. So I'm going to use that comments. So this is this kind of thing I should expect: 1, 2, 6, 4, 5, 12, 7, 8, 18, 10. So what do you see? Normally this was a list from 1 to 10, but by some way they changed all multiples of 3 to be double their number. So this should be 3, they changed to 6. This should be 6, they changed to 12. This should be 9, they changed to 18. So it's like I'm putting a condition for my list comprehensions because I'm going to use list comprehensions here. Please note that you can use Okay, let me use both methods. So this is a more complicated, I want to say complicated anyway, but it's more advanced than the ones we've written before now. So let me use the first method, which of course is longer, and then I'll use these comprehensions to make it shorter. So I start with, of course, let me just start with an empty list. Let me just call it numbers. Okay, numbers, and of course, that's be an empty list. Okay, so I will say for number, this should be numbers. So for number in numbers, okay. Okay, so now look at this. So I'm going to say if, okay, because this is not like a, this is not like how will I put it? This is not like the general kind of just adding append. There's a condition in this case. There's a condition here. So is that condition I want to put with this if statement? So I'm checking first that if if number, okay, just one percentage, okay, divided by 3 is equals to 0. So this is how to know 0, of course, multiples of 3. Because when I divide a multiple of 3, there should be no remainder. Okay. So I'm saying if number plus 3 is equals to 0, then I'm going to do what? I'm going to append. So I'll do numbers dot append. What am I appending? I'm going to append number, okay, times 2. Oh, sorry. I'm going to append number times 2. Okay. So for where I have a multiple of 3, I'm not appending just number. I'm multiplying that number by 2. Okay. Else. Okay. So these are cases where, of course, the numbers are not multiples of 3. So that would be this 1, 2, 4, 5, 8, and 7, 8, 10. So in these cases where my numbers are not multiples of 3, what will I do? I'll just append, of course. I'm not going to append that number instead of appending number times 2. I hope this makes sense. Okay, Olaye said she didn't understand. Okay, this is just the normal. This is like the normal. Of course, create an empty list to do then append. Okay, this is a normal thing we've been doing before now. It's just that this time we are creating a condition somewhere that for anywhere we get multiples of 3, we should double that number, and that's what this code is doing. Okay. Normally, this should have been the code I should write, right? Normally, I should have, after this for number in numbers, I should have just done numbers with append number. Okay. But in this case, since I care about multiples of 3, I have to put this if statement there. And that's what this guy is doing. Okay. So I'm putting this guy to check if it's a multiple of 3. And that's what this guy is doing. So I'm saying if numbers modulus 3 has no remainder, which shows that yes, it's a multiple of 3. Then you're not just appending number as you can see here. You are rather appending the number times 2 because that's the kind of list I want. Okay, 6, 12, 18. So I'm applying numbers times 2 rather than just appending numbers. I'm appending numbers times 2. Okay, so that's what that does. Okay, so if I print number, so if I print numbers, it should give me. Wait a minute. Numbers. Why is it giving me an empty list? Strange. Numbers is equals to an empty list. Numbers to append numbers. Or perhaps it's this number and numbers that's confusing me. Maybe I didn't append this guy well. Interesting. So let me just do this first of all. To confirm that I'm doing the right thing. Okay, I'm doing nonsense. It's not my conditions that's giving me problem. I'm doing nonsense. So this should give me the. Oh goodness gracious me! I didn't actually create this list. Nobody told me. Right? Numbers was an empty list. Sorry about this, guys. Number was an empty list, right? Numbers was an empty list, and I'm looking over an empty list. So when you look over an empty list, there's nothing you do to always give me an empty list, okay? So this should have been range of 10, sorry. This should have been range of 10. Okay? Range of 10. So this should have been what I'm looking over. I'm looking over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be range of 11, in fact. So I'm going from 1 to 11. Okay? So this should have been what this should be what I should have done. Okay? Okay, so sorry about that. I was looking over an empty list. So definitely it was giving me an empty list. So I should have looked from the range of 1 to 11. So this is like I'm looking over from 1 to 10. Okay. So let me run this again. And then it gives me what I want. So I guess that's okay. So now let me do the second one-line method, which is list comprehensions. Guys, please understand list comprehensions. It will save you a whole lot of headache. Imagine all these things I'm doing now. I'll do it in one line. Is that not interesting? So let's do it in this. Let's do it with list comprehensions now. So of course, I create a list and I say X. Okay. Okay. So I say X for X in right. So I say X for X in range of 1 to 11. Let me print this out first so you guys can see it. So it's printing, of course, 1, 2, 3, 4, 5, 7, 9, 10. Okay. But I want to add a condition. Okay. So normally when I'm adding a condition, I put it behind. Yeah. So I'll say if something, something. Okay. But when you're adding the else statement of that if condition, I put it just here. Because I want to tell you straight out that, okay, do X if this thing, else do something else. Yeah, I said do else. I mean, append this, append the double of the number if X is, if X divided by 3 is equal to 0, okay? Else just append number. So in fact, let me do that here. So I'm going to do X, okay, times 3 if X, okay? I mean, sorry, this should be X times 2. What am I mean? X times 2, okay? If X, modulus, what's the modulus sign? Modulus of 3 is equals to 0. Okay, guys, does this make sense? First, before I go on, let me know if what I did here makes sense. What I did here right now is just everything I did here. Just everything I did here. What I'm saying is that for this code, right, it should do X times 2. Remember, I told you when you're doing this comprehension, the first thing is like you tell it what you wanted to do first off. Okay, so you tell it what you want this guy to do first off. What I want you to do is to multiply the square, I mean, multiply any number that is, a multiple of 3, multiply that number by 2. So now I'm telling you to do X times 2, but not for all numbers. Only if the number divided by 3 is equal to 0. I mean, if the number modulus 3 is equal to 0, that means if the number is, of course, a multiple of 3. Okay, but if I run this code, what's going to happen is it's only going to give me the list for numbers that is a multiple of 3. Let me show you. Okay, what's that? Coming. So it's telling me versus now. So X. Okay, I said that this should be actually behind. Some funny things in Python actually. This should actually be behind. It's only be in front when I'm adding an else statement to this. So guys, take notes. When you're putting this condition without an else statement, it should be after your for loop. So I'm putting this if after the for loop. But in the next stage, where I'll put my else parts, okay, I should put this if statement right after my declaration of what I wanted to do. So let me run this now. Okay, as you can see, it printed 6, 12, 18. Because what this code did, all right, what this code did was that it only gave me the number where this is a multiple of 3, where this condition was satisfied. That was the number we printed. But that's not what I want. I wanted to print the other numbers just the way it was if it's not, a multiple of 3. And this is where I should put my else statement. Okay, so I'll say, remember I said whenever you're working with else, it must be immediately after my declaration. So I won't put it behind here. I'll put it forward here. So I'll put it here. Good. And I'll say else. So else. So it's telling me that, okay, do this like I've done if X was a multiple of 3. Else do what? Leave it the way it is. So when it's not a multiple of 3, what I should list do? You should just print that number. Okay, so yeah, 1 was not a multiple of 3, so you just printed 1. Yeah, 2 was not a multiple of 3, so you just printed 2. But yeah, 3 is a multiple of 6. Yeah, 3 is a multiple of 3, so you're going to do times 2 of 3. Okay, which was what, of course, happened the first time. But yeah, where it's not a multiple of 3, I should just print that number. So I'm going to do else x. Okay, so if I run this down, it's going to give me this. So yeah, as you can see, we did 1, 2, 6, 4, 5, 12, 7, 8, 18, 10. So all this was done, with just one line of code. So if you guys understand these comprehensions, let me see your hands. So I understood these list comprehensions, this list comprehension that I wrote here. Very interesting stuff. Let me just see your hands, or say something in the comment section if you understood what I did. Okay, if you understood what I did. Okay, let me just say that this list comprehension was broken into how many parts? I can't. So this is like the first part, declaring what you wanted to do. Okay, this is my second part. Okay, I'm putting a condition. This is my condition. So I'm printing normally. I'm doing x times 2 if. Okay, I'm doing x times 2 if this happens. Else, I'm printing just x. Okay, and then this is my last part of this compression, which is the for loop. So I'm doing all this for what? So I'm printing for x in range of 1 to 11, and that's it. So it's broken into, let me just say 4 parts or 3. First part, declaration. Okay, second part, condition. Third part, the loop. Okay, so this is how a list comprehension works. But remember, if you're not using this else, okay, if you're not using this else, say I don't care about when it is not a multiple of 3. When it's not a multiple of 3, don't even add it to my list. I'll take this out. And once I'm not adding an else statement, this if statement will come after the loop. Okay, so it will come after the loop. And then I run this. You can see it just threw away numbers that were not multiples of 3, because I didn't tell you what to do when it's a multiple of 3. I just said print x times 2 if this happens. I didn't tell this guy what to do when it wasn't a multiple of 3. So guys, does this make sense? Okay, so that's great. I'm quite impressed. I mean, to know that you guys understood what I did. So let me just go to the last one, which I think is the interesting one. In fact, what I'm going to do is I'm going to copy the question and then I'll paste it here. Okay, so you guys will understand what I'm doing. It won't be oblivious. So this is the question. So let me create, of course, a multi-line comments. Okay, so question. Okay, and then poof. So this is my question. I said create a Python class. Okay, I'll take the diameter of a circle. In the class, create two functions that return the area and circumference of a given circle. Okay, let me break this so it's nicer, so you guys can see it in that one. Okay, yeah, I guess, yeah, this is nicer now. So I said create a Python class that take the diameter of the circle. Okay, so I'm creating a class, and then what that class will take is diameter of the circle. Okay, so I'm creating like a parameter called diameter. Okay, and so in that class, create two functions. Okay, so let me take it one step at a time, so I don't go too fast. So I don't run that. Okay, so now let's go. So it said I should create a class. Okay, I create a class. Okay, that takes down the circle. So of course, when I'm creating the class, I have to give the circle a name. So I'm just going to call this class. When I'm creating the class, I have to give the class a name. So I'm going to call this class circle like this. Okay, and then of course my column. So now it creates, of course, an indentation for me. So it says that I should allow this circle to have a diameter. Okay, it means that whatever circle I'm creating, I should, give this circle a property called diameter. Okay, so I said an object in Python is anything that has a property and a function. Okay, so property is just like, okay, of course we are humans, we are an object. What do we have? We have hands, and the hands have a function. Hands can be used for eating, can be used for playing drums, can be used for doing whatever. Okay, so that's what an object is. In fact, an object, anything that you call an object should have those things. Should have a property. Some people may call it a metadata. Okay, so it should have a metadata, and then it should have a function. Okay, so there are some objects that you want to straight immediately. Okay, you want to immediately give some property. For instance, if you're creating an object called a car, okay, one property you may want to give it is that all cars would have tires. Okay, all cars would have tires. So one of the property you want to give all of the cars is tire. Okay, but some cars may not have maybe 6 tires. Okay, while some cars will have 4 tires. So that can change, but all cars will have tires. Okay, so when you're going to give a property that you want it to be instantiated, okay, or you want it to be called for all the objects you create inside that class, you must use the init function. Okay, so the thing is, this init function calls itself automatically. Once you call this class, okay, once I declare this class forever, that init function is going to be passed automatically. Okay, so if, for instance, I'm trying to create a car again, let me use that car example. Automatically, I must tell the program the number of tires I want. Okay, if I create that property inside my init function, automatically I must do that. But if I create some other property inside another function, for instance, let me say I now want the car to move, and then I want to create a property that will define the speed of the car. I cannot define that property inside another a function called whatever. So I can call the function move, okay? And then I'll say, okay, when the car is moving, define the speed of the car. Or when you want this car to move, which means when you're calling this move function, define the speed of the car. Okay, so I hope that makes sense between the init function and any other function inside a class. Okay, so the init function gets declared automatically or gets called automatically, while any other function you create after that init function can be declared. You must declare it specifically, or you must call it specifically. What am I saying declare? You actually call a function, you don't declare a function. Okay? Some syntax, some fancy words, too many fancy words in Python actually. So I should use call. Okay, so I must call other functions myself, while the init function I should not call myself. Once I call that class, the init function will get called automatically. Okay, so I think I've done enough explanation. Let's get into it. So I said the circle should have a diameter. Of course, I want any circle you're creating, any object of circle you're creating should have a diameter. So I'm going to create that diameter property, okay, inside an init. I'm going to create it inside an init function. Okay, so let's begin. So of course, to create the function, I use def keyword, and then init is of course double score 8, like so. Okay, and then like I said, of course, I've talked to you guys about creating, functions, and then I said that inside this function, you declare the parameters or the arguments you want inside it. Okay, in this case, of course, I want to have my diameter as a parameter. But when you're creating this object yourself, the first argument you should put, okay, whenever you're the one creating this object yourself, which of course I'm doing by this class, I'm creating this class object myself. Once I am the one creating it myself and I'm using this class something, okay, I'm creating my class myself. The first argument you should put in any function you're defining is this self. Okay, by convention, is this self. Okay, what this self does is that it points any other parameter, okay, any other parameter you're passing to the function you're declaring. So it's just like you're pointing other guys to this guy. You're pointing other parameters to this class. Okay, that's what the self does. So you must always instantiate, or you must always pass in the self argument first. But this is only when you're creating this class yourself. In other cases where you're just creating your function without creating the object, it means that without creating the class, you don't have to start with self as a parameter. Okay, but when you're doing it yourself, when you're creating this class yourself, then you must start with this self parameter. Okay, so I hope that makes sense. I'm trying to explain in details what I didn't explain in the last class, so you guys understand OOP to some extent, because you need this. You will need it. Okay. Okay, so now let's run this. Okay, so okay, let's write down. So I'm going to create, of course, my diameter. My diameter is what I said I must pass in automatically. So I must put in a diameter for whatever circle I am creating. Okay, so creating my diameter. Now the next thing is to actually point this diameter to this units or to this class. Okay, so what we do most of the time is just do self dot diameter is equals to diameter. Okay, so this line is just like what I was still explaining here. That I'm going to point every other parameter I'm creating to this self or to this class. Okay, it's just an explanation of what I did the first time. I must first declare it, and I must pass every other thing to it. Okay. If I don't pass every other thing to it, it's just as though I didn't create this diameter parameter. If I try to declare to tell me it wasn't defined because I'm not pointing it back to this class. Okay. So yeah, I think this is the only parameter I was told to do, right? Because it said, of course, a circle should just have a diameter. I think that's the only thing. So I've created my compulsory arguments, my compulsory parameter, which is this diameter. Okay, and I put this in this init function because I want it to get run automatically. Okay, so now the next thing to do now is to create another function to calculate the area and to calculate the circumference. But let me start with circumference. Okay, so of course I'll do def. Now the next thing to do is to give this function a name. So let us call it calculate. Let us call it calc dia and calc circumference. So let us call it circumference. Okay, I hope this makes sense. So let me call it def circumference. Okay, so of course, like I said, the first thing must pass is this self. So am I going to need any other thing when creating my circumference? No, just pi. Okay. And so I'm not going to create any other thing. And in fact, that just reminds me, I should actually import my pi from my maths module. I'll say so from maths, import pi. Okay, so I can use 22/7, fine, but let me just use the normal way they do it. And let me use the pi from Python. Okay, so this way we use 22/7. So apart from this, I'm not going to use any other. I'm not going to create any other parameter to calculate circumference. Just the diameter I've created earlier on. Okay, so I'm not going to create any other argument here. So now the thing is, inside this def function, what do I want to do? I want to create or I want to I want to calculate the circumference. So I can just call another function. I can call another variable circumference. I can say circumference equals to what? What's the formula for calculating circumference of a circle? I think it's pi times d. So I'll just say pi, okay, times d. Now d is my diameter, but this is my diameter here, okay? So I've used self.diameter, not just diameter. This self is always very important when you're calling anything inside this class. So I can't just use diameter. I'm doing self.diameter. Okay? So self.diameter. Okay, so I guess I'm done with that. So one thing I can do is just to make it interesting. I say print the diameter. Okay, so let me use an F string because I'm going to put in some variables inside. So the diameter of camera, it should be the circumference. Sorry. So the circumference of the circle with diameter. So let me add this diameter so it looks good. Self.dia. Self.diameter. So let me go to the next line so it doesn't look so crazy. So next line. So with diameter self.dia is what? Is okay, let me move this. I think it's go to another line. Is what? Is equals to circumference. So is equals to circumference. Circumference is another variable, so I must put it inside curly braces. So I put circumference. Oh my god, seriously, time is going. I've never done NumPy and pandas, which I was planning to do today. But I guess it's something you guys might understand. So even if I just brush up on the basics of NumPy and pandas, it's okay. Maybe tomorrow we can just get into data frames and data, and then I'll just bring it up whatever we need to use. So whenever I want to use something, I'll just bring it up. Because the thing is, pandas and NumPy are broad, they are very broad. Okay, so what's going to happen is afterwards, it's whenever I want to apply it, I'll just explain the concepts and apply it. I think that'll be faster that way. So it's going to be, so what is this going to do is guys, going to print out like the circumference of the circle with diameter. What's this diameter I defined here is going to be the circumference that has been calculated here. Okay, that's what this person is doing. Okay, so now the second thing I'm doing is to define another function that will now calculate my area. So I'll just call it calc area. Of course, remember, don't forget the self. And then I'm going to print area, calculate area. So what's area? Area is pi d squared over 4, right? So it's going to be pi multiplied by, okay, multiplied by d squared. Okay, so let me put down d squared divided by 4. Okay, so this is the area formula for calculating area. So I can now say print, because I'm proud to type or I'm lazy to type, and just copy all this. Okay, so I'm going to copy all that, paste it here, and then I'm just going to change area. So the area of the circle with diameter, self the diameter is equals to area. So guys, this is the solution to the second one. Okay, so let me run this. I hope I don't get any errors. Get an error. Okay, I don't want to put this there. Let me just put this in. I don't want it to extend to the place where you guys will see. Do you get? But if I continue this president on a new line, it's going to get into places where you won't see, and I don't want that. So let me just put this backward slash. This backward slash is kind of, it will create a it's just to show tell Python that okay, it's still in the new line. Okay, so let me run this again. So it runs successfully. Okay, so I've created a class called circle. So now the next thing is now to instantiate different objects. Okay, so of course I can now create as many circle objects as possible. So for my question, he now said I should create 2 instances of the object. So the first one should have a diameter of 3. The second one should have a diameter of 7. Then I should call each of those functions that I created earlier on to to calculate area and calculate circumference. Okay, so I can now create as many instances of this object. Okay, so it's just like I created the framework for creating any objects. Okay, and then afterwards I can now use that framework and just adjust whatever parameter. I hope this makes sense about creating a class and instantiating that class. I hope it makes sense. Let me know if it makes sense, guys. Again, I'm saying that when you're creating a class, you're kind of creating a framework. I can see nothing happened here, because really nothing serious is going to happen. Okay, nothing is going to happen until I now use it. So it's when I want to use it, Python will now say, okay, it means I have to get back to all this code and peruse the entire code. Do you get? But at this point, nothing serious is happening. Okay, so the next thing after creating this framework, I can now start creating different examples or different copies of that class. That's the way of instantiating a class. Instantiating again is a fancy name. You get a lot of fancy names in just some big grammar. It's just like you're creating another copy. Okay, you're creating another copy. By the way, this init is called a constructor. I think you guys maybe want to know the fancy names for all these things. So this is called a constructor. Okay, so yeah. So again, let me know if you guys understood what I've been talking about in the past couple of minutes. Okay, so yeah, that's the idea of object-oriented programming. Okay, just about creating objects that can be reused later on. So now let's create the 2 instances of the class. So the first instance, let me call it TIMEYS circle. Just something I didn't plan for here because I saw Timmy on my screen. What's my underscore? Okay, TIMEYS circle. So TIMEYS circle will be, of course, an instance of this circle class. Okay. Then I said that when you create this init function, any parameter you define here must be passed immediately you define it. So once I'm calling this class, I must pass in the parameter that has been defined here. Okay. So if I run this, it will tell me that one parameter was not given. Let me run down and you see what's going to say. So you can see it's missing one required argument. Okay, it's missing one required argument. That's because this guy was inside my init class. I don't want to confuse you, but let me copy this same thing here. Okay, let me copy this same thing here and paste it here. Of course, I have to call it diameter. Okay, so let me now comment this out. So if I do this right now, it's going to run smoothly because at the point of calling my class, since this diameter argument was not defined inside an init function, it's not going to require this code just yet. It's only going to require the code when I'm now calling this class. So let me run this code now and see what's going to do. What's going to happen? Okay, I didn't rerun this. This was a mistake I made in last class, giving me a lot of problems. So I should have run this code. So let me run it and run again. So you can see that I didn't define any argument here. I didn't give me any problems because I didn't define this diameter inside my init function. Okay, it's only when I'm now going to define or is going to call this circumference that is going to now ask me for this parameter. So let me also do that. This is not what I want to do, but I just want to show you guys the importance of an init or a constructor. So let me do calc circumference. So of course, this doesn't make any sense. It should be in small letters. So TIMEYS circle. Oh, shit. Okay, so TIMEYS circle. Not copy dots. So now I've created an instance of this class. If I now try to call this function, okay, this function that I've defined, okay, from this instance, you've realized that it's going to give me an error because now it needs this argument because I'm calling this class, I'm calling this function myself right now. I'm calling it. So once I'm calling this function, I must define this argument. So if I run this, it's going to give me that same error it gave me. Okay, so you can see missing unpositional argument diameter. Okay, so this is not what I wanted to do. So let me go back to the very beginning, and then I come here, uncomment this guy, uncomment it, remove my diameter parameter from here, remove this self also from here. Okay, so let me run this again. Good. So now I have to pass in my diameter, and I've explained. So from this question, it said the first one should have a diameter of 3, second should have a diameter of 7. So TIMEYS circle have a diameter of 3. Okay, let me run another circle. Let me call this one Joseph circle. So this was Joseph circle. Joseph circle it's my underscore. Okay, Joseph circle as it does. So it's, of course, I'm creating another copy. Okay, or you can say I'm instantiating. Grammar. Fancy words. So I'm instantiating this class, this circle class again. Okay, but this time it's for Joseph. So this is Joseph circle, and then this time this one has a diameter of 7. Okay, so what's that? Diameter is not defined, really. Then I run this again. Have you started our diameter is not defined? See that. Just give me a moment. Show me define diameter. Sorry, let me just see again. So def init self diameter. I define my diameter. This guy's okay. I don't make any mistake here. Self of diameter is diameter. But I thought we ran this at first, right? We ran this at first, and then you ran to this one. Okay, let me remove. Let me see. Maybe this code is not. Okay, it's telling me that. Yeah, that's good. So if I should run this, if I should put in my diameter here. Okay, which is my first one here? Really. Am I making mistakes? Let me show I'm not making any mistakes. Because is anybody's see any mistake, maybe spelling mistake or something. I don't. Let me check this one because it's quite shocking. So seven times. Or maybe this kernel has been messed up. Let me just start this kernel. Maybe creating and all those stuff. Let me just start this kernel. Maybe I've messed with the kernel the way I was creating, and that's one thing about Jupyter Notebook sometimes. Sometimes it just does all this. So let me do it again. Okay, you can see this one is going to run. Okay, so this first one should be 3, this second one should be 7. I can see it run. So software Jupyter Notebook can be very funny because I was creating my different. It has saved that thing somewhere in memory. If I were using VSCode or something or other notebooks like that, what's going to happen is it's going to use the latest code I'm writing, not some code that has been deleted. Do you understand? So that's what was happening. I guess that was happening. So yeah, so I created my 2 copies of my circle. So I call the first one Timmy circle. I call the second one Joseph circle. Now Timmy circle has a diameter of 3, and then Joseph circle has a diameter of 7. So now the last step, okay, the last step right now is to now, of course, tell Joseph or tell Timmy circle or try to calculate the circumference of Timmy circle and then calculate the area of Timmy circle. And of course, I'll do the same thing for Joseph circle. So let me start with Timmy circle. So the first thing I'll do is Timmy circle dots. Okay, so use these dots to access the functions inside that class. Okay, so it's like a method actually. Once a function is attached to an object, it's called a method. A function and object and a method are the same thing, but what differentiates a function from a method is that a method is always associated to a class. In this case, this function that I created here, okay, is associated to this Timmy circles class or Timmy circles object, sorry. So therefore, I won't call it a function anymore. I'll call it a method. Okay, so I want to try to calculate the circumference of Timmy circle. So I use dots and I'm calling this function. Okay, I'm calling this function. This time, since I'm not passing any argument after self, I don't need to pass any argument here. Okay, so by default, once I do this, it's going to run this code here. It's going to calculate the circumference. Okay, then it's going to print the statements. Okay, so after that, let me run this so you guys will see. So you can see telling the circumference of the circle is 3. Yeah. Okay, the circumference of diameter. The circumference of the circle with diameter 3 is 9.42. Okay, so I can now finish up all this guy by doing Timmy circle. Okay, dot calc area. Okay, and then it's going to print both. What's going on again? This is not defined. Oh my god, I used D right instead of self dot diameter. That's a big error. So this should be. I was writing the formula the way it was coming in my head. So this should be not D or self diameter. So we want this again. So yeah. So the area of the circle with diameter 3 is that. Okay. So I can do the same thing for Joseph's circle. So I'm not going to because I'm lazy. I was going to copy all these studies and change Timmy's circles to Joseph's circle and change Timmy's circle again to Joseph's circle. And I run that and see that this time because diameter is 7, it's no longer using 3, it's using 7. Okay, because Joseph's circle, his diameter is of 7, and then it prints out the diameter, the circumference, and the area. Okay, so this basically is what object-oriented programming is about. They have there are other properties of object-oriented programming which I wouldn't go into yet. That's what we talk about polymorphism, inheritance, and all those stuff. But I would say it's beyond the scope of this class, right? So for now, guys, I think it's just important for you guys to understand how this works. Okay, and then one interesting thing is that I cannot use this block of code in another code entirely where I've not used or where I didn't create this function. And that's the essence of Python, really. I can use a block of code that someone in Singapore created. Okay. Once I just need what I need to have is the Py file. Okay, and then I can import that file into my own code and use the functions he has created there. So in fact, I'm going to end this OOP class or OOP section with that. So I'm going to create another file file and just import this guy. Just where be import. For instance, I imported what Py from maths. Okay, this maths is a Python file somewhere. When you're installing Python, okay, Python automatically install this math library. So inside this math library, there was a file called maths.py, and inside this maths.py, there's a function called let me go over it again because I think I'm making some mistakes. Okay, so this from maths import py means when I installed Python, okay, there was a file called maths.py. It means it's a Python file. Okay, now inside this Python file, there was a function called py. Okay, I said the right thing the first time, but do you know what's confusing me? Maths.py is this. Okay, why pi is this? Okay, so yeah, I was right the first time. I thought I was using pi instead of pi. What I meant was pi, py. Okay, so let me repeat myself again. This statement means that in this my system like this now, all right, in my virtual environment, there's a folder called maths.py like this. Okay, and inside that code called maths, saved as math.py, there's a function called py. So there will be something like def py, and then all the function and everything. Okay, so I hope that makes sense. I hope it makes sense. So now what I'm going to do is that I'm going to create this object somewhere, and then I'm going to import this thing I did now, this functionality I've done. Okay, this functionality I've created, I'm going to import it into a code that I didn't do anything like this, and I'm still going to be able to use these functions. Okay, I'm still going to use this circumference function and this area function. So enough talking, let's get to work. So let me just copy all this code. I'm not going to use Jupyter Notebook for this because Jupyter Notebook work with IPYNB, as you can see. IPYNB is an IPython notebook file. Okay, I need a Py file directly. So I'm going to use VSCode. So let me move to VSCode. Let me open the VSCode. So let me stop my sharing. Okay, and move sharing to VSCode. Okay, so this is my VSCode. Let me create a new Python, a new file. Okay, so I created too many files. Okay, so close this. Yeah, so good. This is a Python file in VSCode, for instance. Okay, so let me rename this file. So let me just save it. Let me save this file, for instance. So I'm going to save this file. Yes, this is the location of the file, right? So let me just save this file as created class dot py. Okay, so I'm saving this file as created class.py. So this is the class I created myself. So let me paste the entire code there because I don't want to write any more codes. Okay, so yeah, I've done that. So let me save this. Okay, so now the next thing is to create a fresh Python file, a fresh file. So let me just okay, let me cancel. So let me create another file. Okay, so I'm going to save that file as fresh, not anything anyway, it doesn't matter. So let me save as let's call it as fresh. Okay, fresh.py, it doesn't really matter. So I'm saving it as fresh.py. So now what I was pointing out is that I can import this entire functionality. Okay, all these things that I've done, I can use it in this fresh.py. Okay, and what do? I just have to import. Okay, I have to import the name of this Python file. So the name of this Python file is what? Created class. So I'm going to import created class. You can see that one thing about VS Code. It even brought it out for me. It has been added to one of its modules. So I'm going to click on created class. Okay. So if I import created class, it means that I cannot access all these guys. So I can access this circle class, and inside this circle class, I can access these two functions. Okay, but since inside this module or inside this file, there's a class. It's always good to import this way. So instead of doing import created class, what I can do is I can do, let me comment this out. Let me just say from import, okay, from import created class. So I'm writing from created class, okay, import this class. Okay, so this is just like, because inside this module or inside this file, there's another class. That's why I'm doing this. Okay, it's just I could have done this way, but it's not good practice, because anytime I now want to use this function, I have to do something like created class dot circle. Okay, but I don't want to do this all the time. I just want to do circle whenever I want to use that class. Okay, and that's what I'm doing from created class import circle. So from this file, I'm importing this class. I hope it makes sense, guys. I hope it makes sense. From this file, okay, so I'm telling Python, okay, that from this file, imports this class. If this was just a normal def without any class and all, I can just do imports, that class without all these from this one, import this one. But when you have multiple, classes inside, it's always good to start with a from, then import the file, and from that file, imports the class. Okay, so that's the first thing I'm doing. So this line means that I am importing this class from this file. Okay, so that's good. So now the next thing now is create instances. Okay, so let me find a name to use. So I can see ADBC and Adebayo. So let me just say this time ADBC circle. Okay, so ADBC circle. So I'm creating an instance. I'm creating a copy of my circle now. So ADBC circle will be equals to, of course, an instance of the class. So I'm just going to call that circle. And then let's say ADBC circle is much more bigger than the other. So ADBC circle has a diameter of 15. Okay, so let me create another circle, Adebayo. My hand is called. Okay, Adebayo circle. And now Adebayo circle is quite a small circle, so you just have a diameter of 2. So I've created 2 copies of this circle class. Okay, so I can do all the all the stuff I've been doing. Say for instance, I want to print what I want to. Yeah, let me just call I want to calculate the circumference of ADBC circle. So I'm going to do this. I'm not going to from ADBC circle. Then I'm going to access the functions under ADBC circle. Of course, one of the functions created was calc. You can see that by default, this guy has already imported all the functions inside this guy. Okay, so let me say I want to calculate the area of ADBC circle. I'll do that. Okay, so let me now say, let me just do this to give a space, a lot of space. Okay, so the next thing is now, let me now say I want to do ADBC circle. For ADBC circle, I want to calculate the circumference. So I'm going to do ADBC.calc circumference. And then if I run this now, okay, let's see what's going to happen. So you can see that it worked. It told me that the area of the circle with diameter 2 is that, and the circumference of the circle with diameter 15 is that. So you can see that I use these objects without creating them in this class. I only imported them from here. So I'm kind of accessing everything, okay, inside this guy with this statement. Okay, with this statement. Okay, with this. Okay, with import created class, I'm going to access everything inside this file. But since I have specified that from this guy import only circle class, it means that I'm going to access everything here. But in this case, since we used only one class, it's not going to make any difference. But there are cases where I can define more than one class. Of course, I have to specify the class I want to import. But if I want to import everything, every single thing that is inside that file, what I'm going to do is import created class. Okay, so this way I'm going to access everything that's inside that file. But to access a particular class, I'm going to say from created class import this class circle, and then you can see I was able to instantiate. So I was able to create 2 instances of the circle. I was able to use the functions inside that circle class. So this is how to use functions, classes from other places. So I hope it makes sense. I really hope it makes sense. We spent a lot of time doing this, but I really do not regret it because I really did not regret it. Joseph, I didn't get what you said. Did you declare D to be equivalent to diameter? No, we did not. That D was an error. It should have been set the diameter rather than just D. And I fixed that. Okay, so guys, that's it. I hope you guys understood what I did. I hope you guys understood what I did. I hope you guys understood what I did. Let me know if you didn't understand what I did. After now, this video will be uploaded on YouTube, right? So just watch it over and over and over again. I believe I was explanatory enough. So if you watch it over and over again, you will see why I said what I said. Maybe the second time, maybe the first time, maybe the third time. But if you keep on watching and you practice, please, you practice. So it doesn't take anything for me to also create this in your class. After now, create this also, and just see how it works. Experiment yourself. Okay, so you do it actually to confirm that you understand. All right, so before I go on, I need to talk about NumPy because we'll be using NumPy for data science, and I think it's high time we actually begin to talk about NumPy and Panda. So in this class, I'm just going to scratch the surface of NumPy, and then we'll call it night because I'm tired. All right, so let's just talk about NumPy. So let me move back to my let me move back to where is my Jupyter notebook? Yeah. So let me move back to Jupyter notebook. Yeah. So this is Jupyter notebook, and then let's start discussing NumPy. Okay. So NumPy is just a library that is used for numerical analysis. So if you want to do numerical computations, most of the time, NumPy array, it's a way of creating arrays. An array is like a list, okay? But you can't do a lot of computations, a lot of analysis or mathematical computations with lists. Yeah, it's better to use NumPy arrays. Okay, so a NumPy is just a library that's used to calculate and do a lot of numerical analysis. In fact, it is called numerical Python. That's what it stands for. Okay, it stands for numerical Python, and that will be using in this class. So since you are going to use it, it's important for us to import it. So it's always good to import NumPy. Okay, so I import NumPy. But most of the time, you don't really import NumPy because NumPy is a handful. It means that whenever I want to use any class, any object from NumPy, I have to do NumPy.something, NumPy.something, which of course make your code bulky. So most of the time, what we do is that we create an alias. Okay, an alias is just like a short form for whatever import statements we use. Okay, so if I want to create an alias by convention, because use as, so this should be something like as. Okay, so now the next thing to put is the name of the alias. So in this case, I want to create my NumPy as NP because this is what everybody does. All right, so yeah, I use NP. Okay, so it means that rather than putting NumPy.something, I'll just use NP.datin. It's to make the code shorter and nicer. So I'm going to import NumPy as NP. And so once I do this, it means that I have access to every class, every object in NumPy. Okay, so if I want to do that, I can just put a dot and press my tab, and you can see all the stuff we can do with NumPy. All the stuff we can do with NumPy. All the stuff you can do with NumPy. You can see there are so many. Okay, so of course in this class, I wouldn't be talking about anything that will not be very valuable to you in real life situations. So I'm just going to discuss the things that you will need critically. So the first thing you must actually know how to do is to convert a list to a NumPy array. Like I said, for a list, you may not be able to do a lot of computations like matrix multiplication, all those matrix addition and all those things. You may not be able to do it with a list, but you can do it in NumPy array. So the first thing that should come to your mind, the first thing you must understand is how to create a NumPy array from a list. Okay, so how do you create a NumPy array from a list? You just use dot array. Okay, so use dot array. So now this dot array, you can of course apply shift enter. You can see it takes an object. Most of the time, you pass a string, a list. Sorry, you pass a list. Okay, so when you're free, you can read about this to just get an idea of what this does. Okay, so if I pass say a list, say 1, 2, 3, 4. If I print it, it will look like a list. You will find a lot of differences. You can see it just printed this the way a list normally will be. But the only thing is that if I now check the type of this, so I type of this, you can see it's an ND array. This means n dimensional array. Okay, so it's no longer a list, it's now a NumPy array. That's the first thing you must understand here. So now I would like you to see array as matrices, because really that's where you can see them to. You can look at them as so you can be seen as matrices. And then of course, in matrices you have a lot of stuff, special matrices like identity matrix, odd, zero, all these things. So you can create all these things as well with NumPy. Okay, so let's say you want to create a NumPy array or a matrix with filled with ones. So the function to use is this ones function, and what it takes is the shape. Okay, so it's going to take the shape of the array. Okay, so if I pass in say 3, it means that it will be a one-dimensional array of 1 row 3 columns. So if I run that, you can see it's 1 row 3 columns. But if I pass in a tuple, okay, if I pass in a tuple of maybe 2 dimensions, let me say 3 by 3, it's going to be a 2-dimensional array with 3 by 3. The same thing goes for zeros. So I can also use np.zeros to create NumPy arrays that are populated with zeros. Okay. So we know that of course if you do something like range, okay, we do something like range, it's going to bring numbers from 1 to 9 or 0 to 9. Sorry. The same thing, of course, when you want to do range in NumPy. So instead of say I want to do something like np.array of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Normally this is what I should do, right? And then it's a NumPy array. But rather than doing this, there's also a range function, but it's called a range. Okay, I don't know why they put the a, but it's actually not a range, but a range. Okay, so when you use this a range function, you're going to pass in, the length, okay, the start and stop, as you can see. So let's say I want to print a number, okay, that is from 0 to 9. So I'm going to start from 0. I'm going to stop at 9. Okay, and then I run that. So I should be 10 first, because when you're doing anything that has to be arranged in Python, it chops off the last index. So yeah, so you can see it does this with shorter codes. Okay, so at times you want to print from 0 to 100. This is a range. We call it with NumPy. It's a range, not just range. Okay, so it prints that from 0 to 100. Okay. There's one thing that you find very useful, and that's the linspace method. Okay, so in the linspace method, so it's np.lin, not line, lin. Okay, these are little mistakes I make while starting out, and that's where I'm telling you guys all these little things to take it off. So this is range, not a range. Okay, this is linspace, not line space. Okay, so what linspace does is that it creates a number within a particular range. It splits that number within how many portions was it to split it to. Okay, so take for instance, I know that for if I'm printing integers from 0 to 9, there are 10 numbers involved, right? Right? There are 10 numbers involved. Okay, so I split it in 10 places. But if I want to print 100 numbers between 0 and 9, how would you do it? It means there'll be integers and there'll be floats involved. There'll be numbers, there'll be decimals. So if I want to print, say, 100 numbers between 0 and 9, what I use is this linspace method. So let me try that so you see. So the first thing when using this linspace method is to, of course, define the start, define the end. So let me say the end is also 10. But how many numbers do I want from 0 to 10? Say I want 100 numbers. So it's going to split these numbers equally so that it starts from 0 and end at 10. So if I run that, you can see it does that for me. So it starts with 0, then 0.01, 0.2. So if I put some numbers that are not so cool, let's use 134. You can see that it must create numbers from 0 to 10, but they are evenly split into 134 places. If you don't trust me, you can print the length of this and run it. You can see it's 134. So it splits this number into 134 even places. Okay, so let's say I want to split these numbers into whole numbers. What I do, is to do this of 11. Okay, so if I do this of 11, it means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it's going to be 11 places that would split this number in integers. If I try to split it in 10 places, it's not going to give me integers. Okay? So I want to split it in 10 places. But if I put 10 here, it's not going to split this guy in integers. But if I want to split in integers, I use 11. I'm just trying to explain that basically what this guy does, okay, is to ensure that within that range, you split it in whatever number you ask it to split. Okay? That's just the meaning of this last guy in this space. So this is my beginning, this is my end, and this is the number of segments you want to be split. This is useful when you're creating plots, for instance. Okay, so if say we want to create a line plot from 0 to 10, okay, you need values in very small portions, so it be a continuous line plot. Okay, so you can use this linspace to make your plots fine. Okay, so it be a fine plot. Okay, let me just let me talk about np.sign, np.cost. So if I do something like np.sign, say 30, it's going to, or 20, it's going to give me the sign of 20. I do np.cost and all those stuff. It's going to do the sign of all that thing. So let me just do one thing very interesting. Say I want to now print a sign graph, for instance. I want to plot what a sign graph looks like. Well, to do plot, what we use is this matplotlib library. Although I don't plan to go in depth to matplotlib library, but let me just apply it in this case. So say for instance, I want to plot a graph. I have to import matplotlib library, but I'm not just importing the module, I'm importing a particular function called pyplot. Okay, so like I mentioned the other time, I'm not going to do from matplotlib import pyplots. Okay, so this is the function I'm using to do plots. Okay, pyplots. But most of the time, people don't use pyplot like that. People use an alias, like I mentioned the other time. So instead of using pyplot.something, I just use PLC. We use PLC by convention. Okay, so this has been plotted. So take for instance, I want to plot a simple line graph where X is numbers from 0 to 30, and then Y is the sign of their numbers. Okay, so what I do is plc.plot. Now this plot takes some arguments. The important argument is actually the X and Y axis. Okay, let me see if you can give me a full documentation. So you can see it's asking me for X, it's asking me for Y. Okay, so let me do that. So what is my X? Let me define X and Y so it's clear. So X in this case are just numbers from 0 to let me say 0 to 15. Okay. So, but I didn't just want to use integers. I want it to be every single detail or every, portion, like a continuous, I don't know, like a continuous number from 0 to 15. So I don't just want numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I do that, it's just going to give me some funny graph that is not fine. But if, for instance, I do something like np.namespace, okay, and I put, say, 0 to 15, and I put like create 100 numbers between 0 and 15, you see that every dot of that number would be very fine. So it'd be a fine, a fine progression of numbers. So my y-axis would now be my sign, okay? So I'm going to do np.sign. np.sign of what? So is the sign graph is going to be sign of x. Okay? So now I can plot x and y. So if I run this, you can see it's a fine graph of a fine sign graph. If you want to make it interesting, I can add titles, I can add legend, I can even add colors, I can put markers and all these things. So we discuss that when we get into using Matplotlib model. But I just wanted to explain the essence of this namespace. So let me now do something interesting. Let me now make this 10. So it means I'm just going to create 10 numbers between 0 and 15. Watch what happens to this graph. You can see the graph is not fine. Because this is like my first point, this is my second point, this is my third point, this is my fourth point, this is my. So let me add markers. Don't be too scared. I think it's markers. Let me just do this. Don't be too scared if you don't know what this is. This is what I want. This is what I want. Okay, yeah. So you can see that this dot here means these are points in this graph. So this is a point, this is another point, this is another point, this is another point. So let me increase this to 100 now. So you see that, yeah, you can see that the points are now very fine. Okay, that's because it created a list of numbers from 0 to 15, but are split in 100 different places. So you can see that the points are now finer and closer, although it is the same graph. Okay, so that's the essence of namespace. It's becoming very handy when you are dealing with NumPy. Okay, we'll be stopping very soon because so let me just talk about using the random functions in NumPy. So there are times when you need to create random numbers, and it's important to know how to use the random function of NumPy to create random numbers. So to access the random function, it does the random dot random. Okay. Okay, so you do random dot random. Okay, so what do you pass inside this random? So the thing is, inside this random function again, there are other functions. And that's why I said that everything in Python is an object, because a function, okay, can have other functions. So just like the and that has the function of typing can also have a function of maybe a more subtle function of maybe pressing the keys or something, or something like that. So inside this random function, there's another function called random. Okay, so I'm going to do np.random.random, and then if I check this, it's just going to ask me for the size. But let's check the dot string. Dot string it returns a float, okay, between 0 and 1. Okay, so what is dot? It just return any random number between 0 and 1. And then this size is just like, okay, what kind of, what's the dimension of the NumPy array to create? So let me say I'm just create 2. Okay, so it's going to create an array of 2 numbers. Okay, random numbers from 0 to 1. Okay, if I do like passing a tuple, let me say a 4x4, it's going to create a 4x4 matrix of random numbers. Okay, so there are other things you can do with this random function. So I do again np.random.randint. Okay, so let's see this what this one does. So this one now creates random integers, okay, from I to low. Okay, am I rushing this NP? You say you're lost. Okay, I'm going to go over NumPy again, but I think I'll be wrapping up very soon. So let me just talk about this random. Then in the next class, I'll go over this NumPy model and I'll go in depth, of course. So let's say I want to create integers. I'm not going to tell it, okay, what will be my low integer or my high integer. So let me say I'm creating integers from 0 to 4, and then I want it to have the shape of a 3 or a 2 by 2 matrix. When I run that, you can see it creates integers from 0 to 4, random integers from 0 to 4 with this shape. So if I increase the shape to say 2 by 3, it's going to do all that again for me. Okay, so there are other things we can do with this random function. So we can also do random dot number, random dot normal, sorry, random dot normal. And then if I want to do this, it's just going to give you random numbers, from 0 to 1. But if you follow this normal distribution, so things in the center are more likely to be, to be printed than things in the edge. A random curve is sort of like a bell curve, so you have something like this. So things in the center here are more likely to be printed. So let me just right now print print stuff. So let me just give it a shape. As you can see, it's telling me that it's basically going to print from 0 to 1, and then what's the size? So let me just see, I'm printing a 3 by 3 matrix again. Z, a 3 by 3. So you can see, okay, it's printed numbers from, it just printed random numbers basically. So I'm surprised why it's not giving me a 3 by 3 size. Surprising. Right? Okay, I think I should have defined this size particularly. So let me define this size. Size equals to 3 by 3. I think we didn't talk, yeah, okay. We didn't talk about positional arguments and all those stuff. Oh my God. That will be the first thing I'll talk about in this class because we've been doing it badly. Okay, the thing is, by default, okay, lock was defined to 0. Okay, and that means where it's basically going to, where it's going to be located, where random number is going to be formed, okay, which is 0.0. Okay, that's like the center of, the whole thing. Okay, but if I don't define this size particularly and I just pass in my arguments, it's going to take my log to be 3, and that's what happened there. Okay, so I have to define this, they call it keyword arguments. So that's by putting size particularly. So once I put size, I'm constraining this particular one to this last guy here. Okay, don't worry, I'll talk about position argument and keyword arguments in this class, but I think it's also very important. But guys, let's stop here. So you can see it printed a 3 by 3 number, a 3 by 3 random number. Okay, so we are going to stop here for now. In the next class, we would seriously going to get into NumPy, pandas, and hopefully by next class we start wrangling data. Okay, so thank you all for your time. Let me know if anybody has any question. I guess nobody has any question. So well, don't worry guys. After now, please Joseph, after now, one thing you do for me and everybody is to, by tomorrow hopefully this video will be out, at least watch this video once, at least if possible watch it twice.